Hello everyone, it's nice to meet a lot of you. We are going to start this webinar in the simulation in defense with ST Engineering, Barco and Airbus. So let's start by the agenda of today. We are going to do a quick introduction, and then I'm going to present the three case speakers of the days. We are going to present two case studies today. One based around the Tiger attack helicopter simulators. Then Airbus will present his project, Sphere, development simulation. And then Barco Simulation will present the industry's most capable projection portfolio. And then why the FL40. We'll do a quick summary, and then it's going to be the Q&A. Please do not hesitate to ask some question. We are not going to disclose any of you because we do know that the defense sector could be sensitive. You can leave also some question with a specific message in order for us to answer it afterward. And our goal is to answer all the question you could get. We are also going to conduct maybe a small poll in order for us to know what you are looking for during this this webinar. I thank you all for being here with us today. So the first key speaker of the day is going to be Quentin Blanchery, myself. I'm a key account manager at ST Engineering Anticipe on the defense and space market. It's been 2 years since I'm working at Anticipe, mostly on simulation for various integrators and end users through French-speaking countries, either on software or hardware, depending on project and customer. Then we will get Stéphane Amerio from Airbus Helicopter. Stéphane is a visual system manager at Airbus Helicopters. For more than 20 years, he is dedicated to computer-generated imagery. He has developed visual systems in many different industries, from major video game studios to space agencies and aircraft leaders. And then the last speaker is going to be Sondre Faustganger, Senior Project Manager at Barco. Sondre is responsible for the global projection product portfolio for the simulation division at Barco. Since joining Barco, previously projection design in 2005, Sondre has brought with him extensive product knowledge and global market experience, with a focus on developing high-end products and assessing customer needs for the global simulation market. His role built on expertise for 25 years in the projectors and visual displays industry, including position with ASK in focus and projection design, making him an expert in his field. So it's been more than 20 years that STE Anticipe is in the virtual reality, simulation and visual display markets, bringing the latest and of the edge technologies to our customers. Thanks to our teams based in France, the UK, Italy, and Spain, we are working in Europe with many prominent players in various sectors. Today, we are here to talk about defense and military, but we are also working for the universities, engineering companies, car manufacturers, and other public companies such as those. We are not only a European leading company in COTS, software and hardware distribution and integration, but also, and more than ever, we bring custom solutions to our customer with partnership-based projects. That's why we are here today with Barco. For more than 20 years, also, we have been partnering with Barco, which is a professional visualization display and technology providers, to bring our customers the simulation solution to fit their needs and goals. As a provider, Barco offers a large range of visualization technologies, such as cutting-edge projectors that we are going to see today for simulation and VR. So now we are jumping on the Tiger attack helicopter simulators. How is this simulator used? First of all, it's a simulator not for training, but more for behavioral studies, benchmarks of new and future systems, future capacities, and also doctrine for the different governments the Tiger is in use. Today, I cannot disclose who the customer is or where he is located, but we are going to talk mostly how is the simulator used and in depth of his characteristics and how we work in this project. The Tiger simulators is based around one sphere for the pilot, one sphere for the shooters, and then a control room to monitor the simulation and the tests that are being undertaken live. An important note is the sphere are not used at the same time, but they share the same workstation for the IGs. The project in itself started 2 years ago, with a simple goal from the customer. It was to upgrade the existing projection system. The basic goal he put on the table was to enhance the quality, the rendering, and the field of view. We will see later these different characteristics. And the other things was to ensure the performance and the preservation of the characteristic over times. He want to use a simulator during more than 10 years. Anticipe worked only on the projection system, and that Thales worked directly with G, Thales View, to upgrade it to the latest version. And the customer itself upgraded the critical component for him, which was the optic fiber. And there is more than 100 meters of optic fiber between each IG and the simulator in itself. He upgraded also the workstation and other sensitive things like that. What we work on the display when I'm saying Anticipe work on the display, and the first thing is the projectors. The projectors in place was Barco Graphics 908. They get, low lumens for what we know now. They were going up to 1,250 lumens, and the resolution in itself was only 2,000 by 1,750 pixels. And we replace it with brand new FL40 4K from Barco. We choose the FL40 mostly because of their lifetime and performance over time. The total cost ownership with the maintenance is reduced. They are easier to use and cheaper in the time of use. The color spectrum change is really good, and they can go up to 3,000 lumens, which was the goals of the customer. And with the constant light output through the lifetime, we can control it during the 10 plus year the simulator is going to be used. And the customer wanted also an upgrade of resolution, and that's why we choose the FL40, because it can go up to 4K in terms of resolution. We also put in place a new auto calibration system based on scalable display technologies with cameras that you can see on the nice pictures the customer sent it to us. It's coupled to the camera because we think it's one of the best and easy to use solution for the customers once it's set up by the integrator. We also provided a laptop in order for the customer to control the calibration process by itself. And last but not least, for the night mode, we are not going to use a night vision goggle, but the customer wanted to use his simulator during night scene, and for that we use the optical blending from GBVI that you can see also on the pictures directly in front of the projectors. The optical blending is for us the only fully effective method of cleaning up the unwanted projection channel overlap region in multi-channel display when we are using night mode. That's why we choose it. And then, of course, in each of those projects, we also developed and put in place a custom. When the customer wants to use his system in night mode, he just have to push a button for that. When he wants to do calibration, it's the same. He push a simple button and it will auto-cal directly. And we also add for the control room some new screen and a new basic setup. Here you can see the field of view. That's why we upgraded the projectors at the first place. The zone in green for the pilot sphere, which is also represented by an A, was the existing field of view. It was it was really small because of the BG 908, and the goal was to go up to the blue zone and to go up to 200 degree in terms of FOV. For the shooter, you can see it was a bit smaller than the pilot sphere, and then here you've got the result. We greatly increased the FOV. We achieved the 200 degree FOV. Horizontally speaking, and at the vertical, you can see, for example, on the pilot on the upper level, the zone in red is what we are covering right now, and for the shooter, it's the line in blue. So we greatly improved the FOV, which changed a lot of things for the pilot and the shooter. And then here you will see a nice pictures of the customer also from the upper level of his simulator. You can see the FOV, a nice field of view. You can see the cockpit also of his Tiger helicopter. Here is a quick pictures, and that's what we produced at the end. The customer wanted to know exactly what the plot resolution was, so we produced for him a quick arc minute by pixel to know exactly how many pixels there is and what is the resolution, you know. And you can see that there is a huge difference because the projectors are placed at the top. There is smaller pictures, smaller pixels at the top than at the bottom, which are represented in blue there. You can note that it's only in 4K resolution. Here is the initial setup, you know, of the sphere. You can see that there is a lower level with the cabin in itself, and the top level with all the display systems, which are composed by the main projectors. The main challenge was that we get only one IG to control two non-identical spheres. What I mean by that is that the spheres were not built at the same times. There is a couple of years of difference when they were built, and it means that they are not exactly physically the same. So the main point is at the upper level, as you can see on those two pictures. The pilot and the shooter sphere are not the same at the upper level, so we had to place the projectors at the exact same place, but we had to build really tailored support to support the projectors in itself, and also we had to create a removable access for the shooter sphere that are really small in terms of the upper level. It was really challenging because we did not get a lot of times. This is a controlled area. We cannot, for example, build or bring, for example, scales or things like that. We really had to build a removable access that has to be removed each time the intervention is done by your team. So it's really it was really the main challenge. After that, the second challenge was to mount the optical blending also at the exact place. You can see the Chronos glass grayscale in the first pictures at your left, in front of the projectors. They are retracted at the moment at the bottom of the screen and will only go in front when they are facing night mode. At the right, you can see the field of view of the 4 channels with the blending of each projectors represented by the different colors. For a perfect optical blending, you must blend a minimum of 15 to 20% of an image between each channel, and due to the position of the projectors at the top of the sphere, the FOV is way bigger at the bottom. In addition to the difficulty of positioning these projectors, you know, at the top in a constrained place, we also had to position the optical blender at the exact same place, and they are mathematically precise tool, and we had to place them really at the exact same spot because it would not have worked otherwise. We also, it's important to note it, use the professional topographer to map each sphere and obtain the exact pattern we needed for the auto calibration. And for that, it was really an intervention of like 2 days of work for this guy to map exactly the sphere and how they are built. And after that, a quick recap of this project. At the moment, the customer is happy. We have trained him and he's fully capable of using a simulator. It's important to note that the goals are met in terms of resolution, of brightness, and field of view. The total cost ownership is reduced. We only had one intervention in 2 years at on site, which is already really low. And also the display system is built to last at least 10 years after the installation, so it is going to be up for at least 2028. And now I will let Stefan present his project. I'm switching right now.
Hello, so I'm Stéphane Ameriot, and I work at Airbus Helicopters, France, Marignan. We are situated near the Marignan airport. So a presentation of the system first. So the Sphere is our main development simulator, what we use at Airbus Helicopters. And you have to understand that a development simulator is not a training simulator. So we are not trying here to train pilots. We have pilots that are already well suited and know how to pilot an helicopter. We use this kind of simulator to develop new flight instruments, algorithm, or even new structure completely. Apart from that, the system is a 8-meter diameter sphere, so quite a large sphere. We have a 190 horizontal field of view. So this spans the complete horizontal field of view for the pilot, and an 85 vertical field of view. And the majority of this field of view is located beneath the helicopter, because this is where the pilot most of the time are looking. They are looking down. And as you can see in the picture, this sphere can fit a variety of different canopy. So each canopy can fit by sliding in and out of the cockpit, and the adaptive structure of this environment allows us to test different canopy, different combination of equipments, and to see how we can work and enhance this. So apparently I had a problem showing the picture. So this is a picture of the sphere. So with the canopy sliding in and out of it. The objective was an upgrade of an existing system. The previous system was very similar to the one that Barco helped us to build. So in the end, we settled for 6 Barco F40 beamers, and each will be fed by 2 PC suited in a 2-column display with a target to having a finite resolution of 4K on each beamer. The main goal of this project was to enhance the resolution as seen by the pilot, to have more luminosity compared to the previous generation of beamers, and to have a great contrast. During the simulation we used to make with the pilots, they aim to be able to look at very small targets at a large distance, and also to look at small details on the ground. The main objective for the pilot here is to get a real grasp of how high and how fast they are going. So they really need this kind of enhanced precision. Here you can see on the picture, we have 3 different cameras that are used for the calibration, and you can have a look at the 6 different projectors. They are organized in 2 rows of 3 projectors each. So 3 projectors on the upper part of the mezzanine are looking downside and lighting up the down below the helicopters, and the 3 on the top row are just illuminating the upper part of the visual. For the calibration of the system, we also put our thrust in a scalable display technology. We've worked a long time with them, and they provide a very easy to set up solution, and the end result is a seamless display with a warping and blending without any visible artifacts. And the F40 also allows us to have a very high contrast and luminosity, and this allows us to very precisely control where we want this luminosity on the end display. Also, with scalable display, we used to have multiple simultaneous calibration in the end. This allows us to have multiple available position for the pilot and co-pilot, each having their own warping and blending. So during the runtime and of the simulation, depending if we want to have the pilot or the co-pilot maneuvering the helicopter, we can switch the calibration at runtime, and each of them will have the correct warping of the display without showing any parallax artifacts. In the end, we have a display that is as realist as we can possibly have to date. And as you can see on the two different images here, we can have display which show details down to a small gravel or down to a blade of grass if needed, without having any seam visible to the pilot, an homogeneous luminosity. This is partly also due to the fact that the F40 has an anti-smearing capability. So during very rapid turn, which are quite often done with an helicopter, there is no longer a blurry mess visible on screen. The image can stay sharp, and thanks to the 4K resolution, we almost obtain a 3 arc-minute resolution, which is quite high for this kind of system. And we have a total field of view of a distance of view of around 100 kilometers in the end. And this allows us to see even near flatland, very high distance mountains. And so the pilot can really feel like they are at home and understand the geography exactly as they would in a real helicopter. Thank you.
Thank you, Stefan. Yeah, I'll spend the next, say, 15 minutes to talk a bit about the training simulation, say, especially for the defense market, some of the, say, the key markets drivers, before I run it off with some product updates. Again, happy to be, say, able to get some of your time. I think in a normal year, most of us probably would have been to the ITSEC conference in Orlando, so hopefully things are back to normal next year. First, a quick introduction to say the Barco simulation division. So as we saw in the presentation from Anticiп and Airbus, as system integrators, they deal with complete simulation system that contains a large number of system components. One of these components is the visualization display solution, which we in Barco provide. So this is an important part of the system as it represents the visual window to the synthetic environment. Barco has a dedicated simulation division with a clear focus on delivering high quality products say, and services into say, the defense market. Again, our products are installed worldwide. We have a global service and support team to back up our products, which is and offices located around the world. So what really, say, drives the defense and training, say, simulation market? I mean, it's of course a sum of a lot of things, but one thing I think we can all agree upon is that say the ultimate goal is to offer say products and solution that improve, say, better and more efficient training, again at lower costs. So let's look at, say, a little, say, historical perspective. We saw from the Tiger sim that there was some, say, old Barco optics, say, which is the good old CRTs. So I would say for the last 10, 15 years, there's been a clear shift in technology from customized to COTS and from analog to digital. So going in from high frequent maintenance, a lot of customized components to what we have today, which we call, say, components off the shelf. Also, say, hugely aided by the rapid development on the commercial and residential markets, especially on the display side, with better image quality and higher resolution. Also, more processing power, and said the tremendous impact the gaming industry had on the say the IG side of say rendering and creating more realistic images. Also, the transformation from analog to digital has also significantly driven performance with the increase in processing power, and equally important, the simplified communication between the different components in a simulator. So again, as technology improves, the requirements for the training devices from end users also increases. So what do this do to the overall market trends? Budget is typically the #1 limiting factor also in the defense sector, both for new training devices and upgrades of existing ones. Real-life training is often very expensive, and quite a few tasks is almost impossible, or it's very dangerous to do in real life. So as a result of the rapid improvements in technology and the performance increase this enables in simulators, it also opens up several new possibilities and opportunities. Increased simulator performance means that both the quantity and the quality of training increases. So more training, but also more complicated training tasks can be shifted from live training to training in the simulator, which saves a lot of cost for the defense sector. And again, adding more training and more complex training tasks also means that the simulators are used more hours in the day. This combined with multi-purpose simulators, for instance, support for several types of cockpits in one and the same dome, also puts more stress on the components and the reliability of the simulators and the systems as a whole. And again, with fully booked training schedules, there's not much room for downtime and maintenance. So how do we address the market challenges? And within the simulation division, we spend a lot of time together with the partners to make sure that we know what the market needs, but on a high level market trends and down to the nitty-gritty product features. And again, as a visual components to the system integrator that operates in the defense market, it's imperative that we have a product offering that addresses what the market needs both today and tomorrow. It's of course important to have the right features as well to meet the requirements, but our core design parameters when we develop new products are based on the high level market trends as discussed in the previous slide. So based on the strategical market requirements, our key product drivers are even better performance and more resolution, long lifetime reliability and linear performance over time to support the increased demand for the high uptime requirements. Again, knowing that budget and cost is also a primary driver and a potential limiting factor, we also have a high focus to develop product that secures a low total cost of ownership. Again, when choosing components and during our product development, these parameters always makes up the core design values. Performance, reliability, lifetime total cost of ownership are important to all of our products. Even though projection is still the dominant visual display technology, we also offer other products in our simulation portfolio. And that's one of the benefits being part of a large visualization company as Barco means that we have an extensive range of visualization products to offer for the training and simulation market. And again, technologies such as LED and LCD panels, they've also now reached a level of performance where it fits some of the application-specific requirements in this industry. And we already have projects deployed with these technologies in the training and simulation market, also within defense, covering both flat and curved screen solutions. And there's always pros and cons on different technologies. But again, our team in the Barco simulation division have the in-depth application product expertise to help and guide system integrators to choose the right technology for the specific application based on the training requirements. So as mentioned, projection is still the dominant visual display technology, and we offer a extensive range of projection product platforms. And for the training and simulation market, this is the well-known F-series products. And over the years, we've had quite a few, say, different products, different technologies in our training and simulation portfolio. But currently, the majority is based on single chip DLP technology, again, primarily due to lifetime and the performance over time benefits. The F-series are also, say, specifically designed for the simulation market to ensure we meet the product requirements, being say motion platforms, high resolution, night vision support, fast frame rates, yeah, and the other, say, key performance. So with all that in mind, I want to spend, say, the last few minutes to introduce our latest product for the training simulation market, which is the FL40 Mark II series. This was the same product that you saw for the Tiger upgrade simulator that was chosen by Anticipe. Again, the Mark II version is the same form, fit, function as its previous version, but it offers 25% more brightness. So in short, what is the FL40? It's a true solid state product with long lifetime. It has a solid state light source. It's a RGB LED light source, no moving components, again, to ensure reliability, high uptime, marginal maintenance, and low total cost of ownership. So this is all, so this means that this product, say, addresses all, say, the key requirements we initially talked about. So I'm not going to go into a full product presentation with specs and details, but I'll highlight some of the product features and the design choices. So again, the key concept design of the FL40, it's around the solid state light source. So it has a dedicated red, green, and blue, say, LEDs. The FL40 series offers all of, say, the typical simulation-specific product features. We have different native resolutions available, and it supports refresh rates all the way up to 240 Hertz. We also offer both, say, internal pixel shift and what we call, say, IG pixel shift for resolutions up to 4K. And again, as training is say becoming a 24/7 task, a lot of training also happens at dusk, dawn, or night. Again, to ensure optimal image performance, the product also offers a full linear dimming from 100% all the way down to 0%, combined with a dual aperture adjustment to further increase the performance for training in low light environments to continuous time of day operation. And say maintenance and recalibration is expensive, it takes time, and it means lost hours and hands-on in the training device. Solid light source and no moving components combined with the linear performance over time means that we maintain the long lifetime and pretty much no required maintenance, which all contributes to the low total cost of ownership for the FL40. Let's see, I'm trying to there. So a dominant scenario where the defense industry is the key driver is for training at night to support the requirements of, say, train as you fight, fight as you train, and also to be able to use the real equipment and to, say, ensure you avoid negative training. We also have the FS40 series. FS just stands for full spectrum. So the FS40 versions, say again, they're also, say, physically the same as the FL40 models. They have the same features and performance, but they offer a dedicated and independently adjustable IR light source, which is typically used for simulators where stimulation of the night vision goggles are required. And again, also to accommodate, say, budget flexibility and training requirements, we support both dual and single input IR plus RGB. To further increase the performance of the FS series and the performance at night, we have our, say, FLDX lenses. which are optimized for contrast performance in the NVG scenes. And these lenses offers more than 3 times the contrast over the standard, say, FLD lenses. Again, this allows you to be able to perform training using the real equipment, and as mentioned, to ensure negative training. So it's, say, bring your own device and the correct equipment. And there's a lot of, say, a lot more to these products. I said we're not going to go into a full, say, detailed description, but say check out our website, or feel free to contact us for more details on this these products. I'm just going to say round it up with some highlights and why our customers chooses the FL40 products. Again, over the last couple of years, there's been a increased demand, say, to save on operational expenses, again, which requires long lifetime, the low maintenance, and the low total cost of ownership. And with the FL40 series, we've done our best to offer a true solid, say, product that fulfills all the market requirements as good as possible. Also, the FL40 capabilities matches the high resolution and contrast levels of competing technologies with its optical scalability at a lower cost. Last, but I'd say equally important argument is our global support services and the partnership that Barco Simulation offers to our customers, say granting access and interaction to the product and engineering teams within the Barco Simulation group. So to that said, FL40 series, and it's our latest contribution to offer better and more efficient training at lower cost, which is in the end what we all strive to do to bring this market forwards. So that's say in short what we try to say offer, and what we feel we offer from Barco Simulation is confidence and insurance. So that's what I had. I'll like to thank you for your attention and your time, and I'll give it back to Anticip and Quentin for questions and answers.
Thank you, Sondre. Just before the Q&A, we will do a quick summary of this webinar. Okay, I will share my screen again. So now you should see my screen. For this summary, I wanted to thank our undisclosed customer that let us talk about the Tiger simulator. Also Airbus Helicopter with Stefan that worked on his presentation. Many thanks. And again, thank you to Barco and Sondre for the presentation during this webinar. Those 2 projects that we presented were more study based, or what Airbus call development simulator, than training simulator that are even more sensitive, but we hope that it delivered all the information that you were looking for. Also during this webinar, you could see that a true partnership between Anticip and Barco can deliver a really good project. Barco, with its solid experience in simulation, and Anticip with its tailored solution for really specific customer and environment, are doing really great things. Each project for us and simulator is different, but with Barco's product and Anticip experience and creativity, we can fit your goals and expectation. Last but not least, we think that simulation in defense is a huge topic, but the main benefits of simulation-based training and experimentation is that it's taking away the cost associated with, as you know it, running vehicles, operating weapon, get a lot of crew, maintaining an environment, things like that. And it's making it a highly cost-effective solution for the armed force in general. You can also run multiple scenarios quickly and efficiently, you know, to do hit and try. And now we are going to switch to the Q&A. So let's see the question. I I've got a first question. It's about the night vision goggle capabilities on the Tiger simulator, I think. It was not a requirement for this customer, unfortunately. He wanted to do night scene in simulation, but it doesn't needed NVGs. He just wanted to use his Tiger simulator at night, but not with NVGs. So we doesn't had to use the FS40. That's why we only choose the FL40. Another question is do we get any customers in India? Yes, of course, we've got customer there. We've got some project in defense and other areas, but we cannot talk, unfortunately, specifically about that. But we can, contact you afterward in order to talk about that. A quick question also about the FL40 against the FS40 MK2, sorry. The main difference is the NVGs, as Sandré talked about that during his presentation. There is a night vision goggle capabilities for the FS, which is not integrated in the FL40. If you want to go more in depth, I don't know, Sandré.
I think you covered the basic differences. So of course, there's a full say software suite with a lot of additional adjustment possibilities on the FS product. So unfortunately, there is no industry standard when it comes to how NVG equipment should be operated. So we just make sure that we offer a solution which is extremely flexible to fit pretty much any requirements.
Okay. Another question is, how did we work with customers on those tailored projects? Because it's tailored project is really different each time, but generally speaking, we are conducting a study before going live, with the real equipment. What I mean by a study is that we send our team on site. We are taking, measures. We are looking at what you want to achieve. If it is an upgrade, sorry, of a simulator, how is it located? Where is it located? What do we have in terms of specific place? What are the IGs? We are really looking in depth of what you want to achieve and what is also your budget, because in terms of display and projection, your budget is a limiting factor sometimes. So we really have to adjust all those things, but generally speaking, we are going on site to talk with you and to really see what you want to do and where you want to do it. I will let maybe Sandré answer the question about the warp and blend on the FL40.
So the question is if we have built-in warp and blend on the FL40. Yes, we do. We have a built-in warp and blend on all these, what we call the Barco poles based, which is a unified electronics and communication platform, which includes both the FL40 and products like the F70 series. You can do this either on the product itself, and also we have an open API that we have given to some of our typical third-party providers. And again, scalable has been mentioned both by Airbus and Anticipe, but also companies like Dome Projection have working interfaces, and you can choose to do it on the projector or on the IG. So we offer both possibilities.
Okay. I will let you answer also the next question, which is our current IG solution is limited to 60 Hz. Does the FL40 have a way to reduce the motion blur?
Yes. So as most IGs are still limited to especially rendering at 60 Hz, we have what we call smear reduction processing, which is a way to simulate 120 Hz performance and hence increasing the dynamic resolution and motion blur for typical DORI requirements. And again, especially with a product like the LED product, because there is no color wheel in that product, it has very fast color cycling. So we have, say, multiple ways and multiple levels of achieving this. And of course, one of the drawbacks when you do, because this is done by dark frame insertion, you will lose brightness, but you will gain, say, dynamic motion performance.
Okay, thank you. Another one is, what is the maximum refresh rate of the FL40? I will let you answer that.
Yeah, so the maximum refresh rate is up to 240 hertz, which is available on what we call, say, the FL40 wide U series, and then on wide Q and say 120, it's up to 120 hertz. But total refresh is up to 240 hertz.
Okay, so it really depends on the platforms that you choose. Can the FL40 go on motion platform?
Yes, it's certified for say shock and vibration full 3G in all 6 axes, and we already have quite a few FL40s on motion platforms already.
Okay, thank you. Another question that we maybe can answer also is, why does it require 2 workstations to drive a single projectors? And also, what kind of CPU and GPU power is required? I can answer a bit on that, but I will maybe let also Stefan and Sondre answer a bit. It really depends on the IG and what you want to achieve, and the resolution that you want to achieve. I will let Stefan maybe talk about his simulator, because he's using at the moment 2 workstation by projectors.
Yeah, we choose to have 2 PC to drive one beamer, just to leverage the power of each graphic card, and not have the graphic card being a bottleneck and not being able to drive at 4K on each projector, while still retaining 60 Hz as a minimum frame rate. So when splitting this in 2, each graphic card only do half the job, and then we can put twice the detail in each image, or twice the resolution.
Okay, thank you. I don't know if Sondre, you want to add some things to that?
Yeah, I can just say, if let's say make a comment, it's if let's say on products like the 40 and the 70, there is no limitations, and why you need to have, say, 2 IGs. It's primarily IG limitation rendering, say, challenges. It could be for if you need dual frustum and you need to render a very large field of view, it makes sense to do say 2 inputs. But again, for as I mentioned, for the FS product, say dual input can also make sense if you want to have a, say, a dedicated database or a visual scene for the visual and a dedicated for the IR to say compensate for type of NVGs you have for the correct performance of night vision goggles stimulation.
Okay, thank you. Another good question is about the maintenance of the projectors. Any parts are consumable items, sorry, any lighting in that needs replacement? To my knowledge, there is no, for example, lamp or things like that to change. It's true solid state. I will let Sondre add things about, the FL and maybe FS also.
Yep, and the FL and FS is the same in regards to maintenance. So unless you use it for pixel shift mode, there is no maintenance required. Again, there's of course some, if you have a very, say, dusty environment, a lot of, say, contamination, this will, say, impact the, say, not the optical system, because that's fully sealed. Also, we have both dust filters and pollution filters that you can attach to the product. But again, the only component up for maintenance is the actuator, and that's due to mechanical wear at 25,000 hours if you do enable pixel shifts.
Okay. Another question is about the FL40 again. LED is RGB LED chip or blue LED plus phosphor? I will let you answer that also if you want to.
Yeah, so so the FL40 is not using blue phosphor. It's a true RGB system. So this with very fast color cycling. So there is no phosphor, no moving components. It's so the colors are say created by fast color cycling on the light source itself. No color wheel needed.
Okay, thank you. Another question is about the presented system that seems to be running in mono visualization mode. The question is, would there be a benefit to using motion tracking system to enhance the immersivity for the trainees? In example, stereo. Do you want to answer that about your system, Stefan?
Well, we consider to have a stereo system, but having a stereo system requires that the helmet of the pilot is modified, and in no way should we modify the helmet of the pilot. We are trying to assess the real helmet, so this is not a way to modify it. So stereo is out of question.
Okay, as for the customer that cannot be disclosed, it was not on the requirement, you know, I think it's the same as Stefan. His simulator is used mostly with the real helmet and things like that, and he doesn't want to use specific goggles or things like that for stereo mode. Another question for the Tiger sim. Why are all the projectors on the upper level? Surely splitting between projectors cluster below and above the cockpit would allow for a more even resolution distribution. I think you are perfectly right. We could have placed the projectors below, but unfortunately there was no place to put them below, and it was only there was only place on the upper level, you know. And if we had put them on the floor, there would have been some problem regarding the the access to the cockpit and things like that. So we had to put them on the top level. Was the scalable alignment integrated with the warp and blend within the Barco projectors on both projects? I will let you answer, maybe Stefan, for your project.
Yeah, so no, it wasn't integrated inside the Barco, but just for ease of usage. Sending it to the Barco required to upload a file directly to the projectors, and this is quite easy to do. So that's not a problem. But we already use a solution that integrated directly in software, so it was just simple to do that. As we have in any way to send the angle of views, the position of cameras to the IG, to the image generator. So in fact, we just send also to the image generator the warp and blending.
Okay, thank you. As for the Tiger, I do think they are integrated directly into the projectors, but I can answer it afterward because I'm not totally sure for that one. But you can do either on the projectors directly in the IGs, or I even do think with the graphic cards. It really depends on if you have access to the IGs or not on and of the type of projectors. Could you explain better the double sphere for the Tiger helicopter for shooter and pilot? It's really simple. The customer built the first sphere. I do think 20 years ago, something like that, dedicated only to the pilot because they wanted to assess behavioral studies based on him first, and they do not get the place to add the shooter directly behind as it is in real life. So they had to build a second sphere dedicated to the shooter. It's important to note again that those spheres are not used at the same time. They are even either conducting study for the pilot, to assess, his behaviors depending on the new doctrine, for example, at the state level, or they are conducting study based on the shooter and his next and new capabilities. So they do not need both the pilot and the shooter at the same times in the systems. It really depends on what they want to conduct in terms of experimentation. Okay, question to Sondre. Is the FL40 a one chip or a two chip projectors? I can answer that it's only one chip, but I will maybe let Sandre answer a bit more.
Yeah, it's indeed a single chip, and that's where I say the RGB concept comes in for full on the light source. Because typically, say when people think about single chip products, they think about a product with a color wheel. I mean that's the magic with the FL40. It's that it doesn't require a color wheel because of its RGB light source, even though it's a single chip product.
Okay, then there is some question about the replacement of the F22 projectors, and also about the when you mentioned the curved LCD and LED panels. I don't remember if it was curved, but is that a single or double curved? Could you answer that? Maybe.
Yeah, so the curved installations we have with LCD and LED panels, it's single, so it's not spherical. It's say cylindrical, so it's not spherical. And in regards to say F22, I would say you never know, but overall it's not that easy to make say solid state products if it's LED or lasers as small as say the more limited say lifetime solutions like a lamp based. So that's the main challenge in regards to compactness is the additional cooling and the size of the light source.
Okay, thank you. A question about the IG that are being used in the example of the Tiger and also for Airbus. And does it need any extra? Oh, sorry. Does anything? Does anything extra needs to be done to make the IG channel seamlessly work with the automated warp and blend to achieve the desired field of view? Do you want to answer that for Airbus, Stefan, or is it confidential in terms of IG?
No, but it's quite simple. If you use scalable display, then you either have to integrate directly the SDK from scalable display to be able to have the IG, the image generated by your IG, warped and blended by the scalable display SDK, or as scalable display just generate a simple text file. You have to find a way to integrate these and parse these and modify your output image according to it. That's just as simple as that. And integrate it, if it's just integration of the SDK, is quite simple. It's just a one function call.
Okay, thank you. And as for the Tiger, I said that the IG used is an IG from Thales, which is Thales View, that the customer is using. We did not get the the ends on the IG ourselves. We had to go through the customer who work with Thales on an upgrade to to put the desired files from scalable display to achieve the desired field of view. So it was quite tricky, but it's all working and quite well. So that's good. Do you have any auto blend and wrap solution? I don't know how to answer this question, because yes, we have in terms of software, and there is also integrated solution in the Barco projectors. On those projects, we use scalable display, and there is other existing one in the market. And maybe Sandre, you want to talk a little bit more about Barco solution?
Yeah, so currently we do not offer a internal auto calibration system, if I understand the question correct. But we do work with third-party suppliers, as mentioned, which will do full auto calibration, both geometry and blending.
Okay, thank you. A question for Stefan, sorry. For the Airbus project, how long did it take to design, implement, and operate the entire systems?
I don't really think the final answer will be relevant, but because what I mean is the system was designed by Antecip, and Antecip already designed and worked with this system a long time ago. So they already knew the setup, they already had the geometry of the spheres, they already knew a lot of it, and moreover, they already worked with me before. So a lot of things went quite smoothly and rapidly, and I'm not sure if it was some different system, things would have been as fast. But overall, I would say between 1 to 4 months would be a good estimate. Before the first, I'm talking about a time frame, not of course working days here. It really depends on your system and how they can evaluate. In the end, the load will be on Anticipe and Barco, not on the customer.
Thank you for your answer, Stefan. And just to add also some information on the Tiger project, I do remember that we achieved. I do think it took like nearly a year to install both sphere, because we installed the first one in say 3 to 4 months, such as Stefan, because we had to wait for the upgrade of the IG, we had to wait a bit for the customer to upgrade his optic fibers, things like that. But generally speaking, it could have been done in 3 months, something like that. And then afterward, the customer asked us to, refurbish the second one in a second time. So that's why we had to wait a lot of time before going there. And after that, COVID happens and things like that. So it took quite a while to finish it in good terms. And I do think there is one last question regarding the 2 IGs per projectors. Are the IGs times multiplexed, or do they cover different parts of each image?
Sorry?
No. Regarding the 2 IGs per projector, are the IGs time multiplexed, or do they cover different parts for each image?
No, all IGs are synchronized. And so they have an internal timer for the software part, and the image themselves are hardware synchronized through NVIDIA Quadro cards.
Okay, thank you, Stefan. That was the last question. We covered them all. Thank you a lot for your time. It was a good hour with all of you. I do think there is you will get some link afterward with the presentation and some more information. We thank you all the presenters and attendees, and see you later for another webinar, I think.
See you.
Thank you.